Hello. Today we are going to start a new course which is machine learning, and in Machine Learning we are going to learn Introduction to Machine Learning. Machine learning is a branch of artificial intelligence that enables systems to learn automatically and improve from experience. It involves the use of algorithms that can learn from and make predictions or decisions on data. Machine learning has a wide range of applications, including data analytics, natural language processing, and computer vision. Supervised learning involves learning from labeled data to make predictions on new, unseen data. Unsupervised learning involves learning from unlabeled data to find patterns or groupings in the data. Reinforcement learning involves learning from feedback to select actions that maximize a reward signal. Problem definition involves identifying the business problem and determining the machine learning approach to solve it. Data collection involves gathering and cleaning the data needed for the machine learning model. Model development involves selecting the appropriate algorithms and building the model. Model evaluation involves testing the performance of the model on new, unseen data. Model deployment involves integrating the model into a production environment for use in decision-making. Model monitoring involves regularly assessing the performance of the model and making necessary updates or improvements. Linear regression is used for predicting continuous numerical values. Logistic regression is used for predicting binary outcomes. Decision trees are used for classification and regression tasks. Random forests are an ensemble method that uses multiple decision trees to improve performance. Support vector machines are used for classification and regression tasks. Neural networks are used for a variety of tasks, including image recognition and natural language processing. Accuracy measures the proportion of correct predictions. Precision measures the proportion of true positives among all positive predictions. Recall measures the proportion of true positives among all actual positive cases. F1 score is a combination of precision and recall that balances both measures. Awk-ROC measures the trade-off between true positives and false positives at different classification thresholds. Confusion matrix provides a summary of the model's performance on different classes. Bias refers to systematic errors in a model that result in inaccurate predictions. Fairness refers to ensuring that the model's predictions are not discriminatory or biased against certain groups. Mitigating bias and ensuring fairness involves careful selection of features and data and regular monitoring of the model's performance. Machine learning can have ethical implications, such as privacy violations or discrimination. Ethical considerations in machine learning involve ensuring data privacy and security and developing models that are fair and unbiased. Regular auditing and monitoring of the model's performance can help identify and address any ethical concerns. Data quality and quantity can impact the performance of machine learning models. Overfitting occurs when a model is too complex and performs well on the training data but poorly on new, unseen data. Explaining and interpreting machine learning models can be challenging, especially for complex models like neural networks. Machine learning is expected to continue to advance and have a significant impact across industries. Advancements in areas like deep learning and reinforcement learning are expected to lead to more sophisticated and intelligent systems. Ensuring ethical and responsible use of machine learning will be critical as it becomes more prevalent in society. Thank you for watching us. Stay tuned for next video.